Hello students, in this video we are going to see some graphs that are used to analyze CVP of single product as well as multiple products. So first let's see single product. Let me take an example. Single product, selling price $10, variable cost per unit $4, fixed cost total $10,000. So one of the popular graphs you draw is traditional break-even chart. How we draw traditional break-even chart is $, number of units. First thing, total fixed cost, that remains constant, 10,000. Whatever the number of units, your fixed cost is constant. That's what you study from the basics in management accounting. Also you studied that fixed cost is constant. That's why we call it fixed cost. Second one, total cost. Total cost. It starts from fixed cost because at 0 units, you have only fixed cost. There is no variable cost. Then when the number of units increases 1 by 1, the variable cost will increase 4 by 4. So one unit will be 10,000 and a 4. Second unit another 4. Third unit another 4. So it keeps increasing at a constant rate. Next one, this will be the total revenue graph. Total revenue. Total revenue will be steeper than total cost. If I erase total cost and draw it once again, yeah, that will be the total cost graph. Total cost. So the point where total cost and total revenue intersect, if you find the x-axis value, that's going to be break-even point. The point where they intersect, if you find the y-axis value, that value will be break-even value. Simple. And couple of other things they can ask. Right, this gap, total cost fixed cost gap, what is this? That will be variable cost, total variable cost. Why? With fixed cost, when you add variable cost, that is what is total cost. And if budgeted volume is marked here, budget, then this gap will be margin of safety units. Similarly, if you mark budgeted revenue here, budgeted revenue, then this gap will be margin of safety revenue. Isn't it? Budget minus break-even value. So these points can be tested. This is for single product. Anyway, at PM level, single product being tested is very less chances in essay questions. Can be in MCQs possible, but multiple product graphs can be connected in your essay questions. However, they can't ask you to draw a graph. So that gives you an advantage. They can give you a graph and ask questions on it. Let's look at one example. Multiple product. Say product P and Q. Selling price 12, 15. Variable cost per unit 4,9. Volume 1,000. Fixed cost, I'll leave one line and write fixed cost. Fixed cost $10,000 in total. You know, fixed cost doesn't come for each product separately, it's the total fixed cost. Right. So if I want to draw this graph, the break-even chart, the traditional break-even chart, how am I going to draw that? Let's see. $, number of units. Fixed cost is anyway the same, nothing to worry, same as earlier. Fixed cost, well, that must be a little straight than this. There you go, fixed cost. How much is that? 10,000. Fixed cost. Now total cost, here it was only one product, so it just increased at one rate. Here you have two products. So if I take P first, number of units 0, let's mark 1,000 units here, 2,000 units here. First 1,000 units will be P. After 1,000 it's going to be Q, isn't it? Because you have 1,000 units, 1,000 units. Can you see 1,000, 1,000? First 1,000 I am assuming P, and the next 1,000 is Q. So first variable cost is increasing at a rate of $4. It's increasing at a rate of $4. Let's see. Okay, that's $4. Then it is increasing at a rate of $9. So from that point onwards, I have to take a higher angle. $9. I actually need the graph only up to 2,000 units. Let's draw it carefully. $9. So can you see it will be a broken graph? Just I don't need the ruler, let me just draw it. This is first part of the graph. This is second part of the graph. This is why lower slope, because it is increasing at a rate of $4. Why it is higher slope? It is increasing at a rate of $9. Okay. Then what you do? We will connect the starting point. Concentrate, this is the important point. Connect the starting point and ending point by one straight line. Look at this. One straight line, must be one straight line. Once again, right. Straight line, must be straight line, huh? Starting point and ending point. Let's try to understand the green line and the red line. What red line tells us is selling the products one by one. P is sold first. You are finishing all 1,000 units of P. Then you are selling 1,000 units of Q. That is this. What is green line? Remember in the multi-product break-even calculations we assumed products are sold at a constant ratio. That means 1,000 units of A, P, 1,000 units of Q means 1:1 ratio, right? If you are constantly selling P and Q together, 1:1, 1:1 ratio, then the graph will be like this green graph. Repeat, red graph means first you are selling only P, no Q. Finish all the units of P. then you are selling Q. That is red graph. Green graph is no, you are selling P and Q at a constant ratio of 1:1. This is how your total cost graph will be. Same will apply for revenue also. If you look at revenue, let me use different colors for that. Revenue. Right. Revenue, if you see, P, it increases at $12. So it's going to be 12 into 1000, 12,000. It will go up to 12,000. Where would this have been? 10, 14,000. Okay. Let's draw with a different color. This color. Okay. Revenue should start from 0, 0 because no revenue. No revenue. No units, no revenue. It doesn't work. Let's take red color itself. Okay. Start from here. 12,000 would be somewhere here. Like this. Then the next product, the price is 15, right? It must be increasing at a higher rate. Remember, once they gave a question and ask also, explain why the angles are different. So, if you are talking about revenue, look at the selling price. If selling price is the one that decides the angle of the graph. So, this is going to be even more steeper. Like this. Why is it steeper? Because selling price is $15. This is increasing at a rate of 12. This is increasing at a rate of 15. Here also, as we did earlier, you will connect the starting point and ending point by a straight line. Clear? So what's the meaning of this green line? If both products are sold parallelly, I mean simultaneously, that means when you sell one P, you are selling one Q also. If you are selling in that ratio always, the revenue will increase according to this green color line. What is this red line? If you are selling all 1000 units of P first, finish it, and then you are selling Q, then this red line is going to be the graph. Clear? Our assumption usually is this green thing. What is it? The products are sold at constant ratio. Then this point reflects the break even. Find here, this will be the break even point. And find the value on the y-axis. That will be the break even value. Clear? This is what we do for multiple product. What is the name of this graph? Traditional break-even chart. Traditional break-even chart. There is another chart which is known as profit volume chart. Let me copy this data. Right, let the rest be there. Profit volume chart. What is profit volume chart? Y-axis is going to be profit. X-axis will be revenue. This is profit volume chart. If it is a single product, it will be just a straight line. Here, since there are two products, one by one we have to draw. Anyway, starting point is going to be 10,000, negative 10,000. Tell me why? Fixed cost. Starting point means you don't have any sales, zero sales, but still fixed cost will be there here. When you finish these P, 8 is the contribution, 8 into 1000, $8,000 contribution it gives you. Let's make a table to understand it better. Number of units, revenue. When you are talking about initially P 1000, what will be the revenue? 1000 into 12. Okay. What will be the total cost? Total cost will be, you have fixed cost of 10,000 plus variable cost of 4 into 1000. Why 4 into 1000? This 4 into 1000. So what would be your profit? The loss 12,000 minus 4,000, 14,000, 2,000. So let me mark a point here. This is revenue 12,000. Remember, x-axis is revenue, and here minus 2,000. This point. Check this. This is my x-axis, guys. Revenue is my x-axis. Profit is in my y-axis. So when x is 12,000, y is minus 2,000. When x is 12,000, y is minus 2,000. Then what do? We will add P1000 and Q1000. So on top of P, you are going to sell Q also. So your revenue is going to be, P's revenue is already there. You had to add Q's revenue. Q's revenue how much? 1000 into 15. Okay, so next point you are going to draw here, 27,000. Right. Let's see what would be the y-axis value. For that I need the total cost. Total cost, with this cost you need to add Q's variable cost. How much is Q's variable cost? 1000 units. This plus 1000 units into $9. Check this carefully. This 14,000 includes fixed cost as well as P's variable cost already included here. So on top of that I have to add Q's variable cost only. 1000 into 9. 23,000. So how much is going to be the profit? 4,000. So at this point it's 4,000. 4,000. I think 10,000 could be somewhat lower than this. 10,000 could be somewhere here. All right. So let's draw the graph. First line and then second line. Can you see it's broken lines? Once again, first line and second line. First line will be steeper. Do you know why? Contribution here is $8, right? Contribution here is only $6. So first one will be steeper. It increases faster. Second one will be slower, because contribution decides the slope of this graph. Then, as we did earlier also, connect the starting point and the ending point. This point. So what is this red color line? Red color line in this graph explains the profit graph if products are sold simultaneously, if products are sold at a constant mix of 1:1, and this would be the break even, what? Not units, because you are taking revenue on the x-axis, break even value. Right, this is what we calculate how? Fixed cost divided by weighted average CS ratio. If somebody asks what is this point, see the green graph where it cuts the x-axis, what is that point? That is the break-even point if products are sold one after the other. That means P is sold first, you finish all P and then you take Q. If you are selling like that, that is where the break-even value is going to be. Clear? That's all the graphs, break-even graphs you have. With all this, with these three, CVP 1 was all about single product. CVP 2 was my video. CVP 2 video was about calculations on multiple products. This is CVP 3 where I have explained you the graphs.